Okay, so what I'm going to do this short video on is on how a three-phase motor basically works, and then we're going to look at some things that go wrong with three-phase motors. Just going to talk about how a three-phase motor works. So when you look at a three-phase motor, you have a stator. This part is what we call a stator, right? It stays still, stationary. Okay, in a DC motor, they'll call it the yoke or the field. So here we have this, we have a rotor inside, okay, and we call this a rotor. So what the idea of the rotor is, it rotates around, it has little bars running around the inside. Okay, we call this a squirrel cage on a three-phase motor, and the same on a single-phase motor. They have a shaft that comes out one end, okay, and it rotates around. On the stator part, we have what we call windings. Now they're broken up into 3 sets of windings for a three-phase motor, or 2 sets of windings for a single phase. So mostly I'm going to talk about a three-phase motor, which is this one here, probably because it's the simplest motor to talk about. Single phase, you've got probably about 8 or 9 different versions. So the rotor, right, acts like a the secondary. So just relate this back to a principle of a transformer. This part is the primary. The reason I'm talking about this being a primary is, right, is we bring in 3 supplies to this, and we call them red or white, blue. So if we have a look on here, we have 3 supplies, red, white, blue, or red, white, blue, and our earth wire over here. So we're going to talk about this and how the configuration of these windings work. So we have 3 supplies come in. They're 120 degrees out of phase, all right? So what they mean there is, when they're travelling along, we have one phase, we have the next one, and then we have the next one. Not drawn perfectly, but they're out of phase. So what this does, it creates a rotating magnetic field. So what it means is, if I put power straight onto that motor, that shaft will start to turn straight away. It doesn't need any starting or anything. As soon as I put power onto these 3 coils, all right, so we have 3 sets of coils for one set of coils for each phase, okay? What adjusts the speed of this, though, is very important. It's called the frequency, right? So the frequency is what controls the speed. And that's what we get, what we call a variable frequency drive, because if we change the frequency, we also change the speed. But also it comes down to torque too. We have a thing here called, you have the number of poles. So the more coils you put around the stator, you actually change the speed of the motor as well. So it's like a 2-cylinder, 4-cylinder, 6-cylinder, and an 8-cylinder motor. The more cylinders I put on each set of windings, so the red might have 4, the white will have 4, and the blue will have 4. That means it's a 4-pole motor, okay? So we call them poles instead of cylinders, all right? So as we start, the motor starts up, we start turning, we have the rotor. Now, the idea, when we look at a lot of motor starters, is the supply. So the supply to the motor is what's fairly important. So I'm just going to change this over here. So when we look at the motor again, just quickly, we put in the 3-phase supply to the stator, okay? So the 3-phase supply is what we have going in. Now, if we want to slow down the motor or do anything, most of the time we do that by dropping the voltage to the motor. And that's what we get on an auto transformer. We get on a, what else do we get? A primary resistance starter, all right? And we also get on a liquid resistor starter as well, all right? So the idea of these 3 is they drop the voltage, and then we also have what we call a star-delta starter. The thing with the star-delta starter, these all have to use an external type of way of dropping the voltage here. So what they actually do is they create a voltage drop before it gets to the motor. With an star-delta, we actually have to put in 6 windings. So we end up with 3 and another 3 going into the motor, all right, to change it. So that's where we get a little bit different with them. I'm just going to talk about star-delta starter a bit, because that's how we can change the speed of the motor, but how motors are wired up a bit differently. So remember, we've got our stator, we've got all our wires running around the outside, coils. Coils make up, now you've got to remember a three-phase motor is an inductive load. It's like a transformer and it creates its own magnetic field. And this is what this does. The stator creates its own magnetic field, and then we have our rotor, which has the interaction with the rotor bars, and that creates the push and pull effect. Okay, so if you think of these as ghost magnets, which means is every time I put power onto them, they keep charging around. If I put a north and south here and we've got bars, it tends to want to push. And then if the next set come around, that will push around again and the next set. So that's doing that pulsing 50 times a second. That means that rotor is going to want to torque and move around. So there's no actual moving parts in there. It's actually what we call pulsing, the ghost magnet pulsing around at 120, out of 120 degrees, it causes the motor to rotate. So as the motor rotates, we create torque. And the thing is with torque is it's measured on the shaft. All right, so we develop torque, we measure it on the end of the shaft. So, and that develops on RPM. So we have things called frequency, the number of coils. So a lot of things come into play on a motor. All right, so if you have a look over here, we have 6 windings. This one's, which we're going to pull apart, we have red, white, blue, okay, and the blue wire. So I'll just take those out for the moment so we can see it individually. We've got the earth wire. So the earth wire, notice it's joined down to the chassis. The idea of that is so that we earth the actual motor. All right, so the difference between these two, just pick up that screw, I don't want to be standing on it. So the idea, and that little clip coming out, oh, I'll get that later. Okay, so here's our three-phase motor. So the idea is we can't have electricity. These 3 windings, so there's a set of windings. There's a set of windings between here, here, and here. All right, depends on how they go. But normally they run one that way, and that way. We don't run them across, okay? So the windings will run across here, across these two, and across these two. And if I measure them, they should be like even ohms across here. So 3 ohms across there, 3 ohms there, and 3 ohms there, of equal value to make the motor work. So we have a terminal block. Look at this on the motor. And if we have 6, we know that we can use this motor for star or delta. If we only have a terminal block with 3 wires coming out, okay, that means the motor can only be used for star, okay? But when we have 6, that means it can be used for star or delta, okay? So, looking at this again, we have 2 sets of windings. We have one winding coming across here, another one across here, and another one across there. We normally call it A, B, C, C, A, B. Other countries use X, Y, Z, this depends. At the end of the day, it doesn't really matter. It's depending on it. You just got to meter it out with 3 windings to start and finish. So when we look at different things than star and delta, okay, so this is a configuration of how the motor and winding. We need to measure the resistances. So basically what we're looking for in the motor, right, and we look at this as our primary, all right, and here we have our secondary, which is our coils, okay. We're going to have an interaction with this. Like any normal transformer, if we have a look at it and we put in our supply and we have our windings, we take power from the primary, goes through this magnetic path, all right, runs around here, and we get power on the secondary. The only difference with this is we've got this little air gap in between, okay, which it means it has to cross and get into the secondary, and that's where that little air gap, we lose a little bit of torque, all right? Okay, so when you look at a motor, the what we call synchronous speed is what we call frequency. That will be traveling at 1500 RPM if it's a 4-pole, just for example, right? And on the shaft speed will only be like something like 1450 or something. Where did the 50 RPM go between here to here? It's called slip. We get slip, we get bearings. It's all different losses that we get together. And that's why the shaft speed is not always the same as what we would see as what we call frequencies or synchronous speed. All right. So, and that's partly from this like little gap that we've got in a transformer that we go from the primary to the secondary. All right. So we've got a little bit of basics there. I just want to talk about how the star and the delta work, how we look at when we wire a motor in star and delta and why there's differences in speed. So when we look at star, we took the windings, we had them one that way, and one this way. So when we look at it, we've got a winding that runs down this way. Then we have our centre part here, comes out again. Now, if you take this into consideration, we're going to look at this as star, all right? We'll just talk about this for a start. So star is basically something that reduces in current, right? And a little thing I look at is V times I. If I drop the voltage, I drop the current, all right? And this is what we're doing here. If we drop the voltage down, we're going to drop the current. So normally we have 3 wires coming in, okay? And then we talk about the links going across the bottom here. And that's what you can have a look on here. If we have a look on here, we've got 3 links joined and 3 wires that would normally come into these 3 here. So red, white, blue, and then we've got our 3 links across here. So at the moment that motor is wired in star. We have the 3 windings joined together here. So if we have a look over here, we have A, B, C, C, A, B. So it's called A, B, C, cab. Okay, so if you look at that one goes to that one, that one goes to that one, and that one goes to that one. So what I'm going to do here, A1, B1, B, C, and C1. Now if you have a look, and these are our what we call our little ones underneath, these are all joined together here, which if we put these 3 together, we end up with these 3 in the middle. And what it is, it's basically between where the supply comes in and goes out. Normally across this point here, we have 400 volts across 2 of the windings. Now these are what we call inductive windings, not resistive, okay? Because inductive, right, create a magnetic field. And that's where we get that resistance of going against the magnetic field. We'll call back EMF and but I'm not going to go into too much of that deep. So if we do something what we call a root 3, which is 1.732, suggest with that, we end up getting 230 volts across each coil, okay? And what that does is we've dropped our voltage. Our voltage now is gone from 400 volts down to 230, right? And same what's going to happen with my current. My current's going to drop down as well, down to a lower value as well. All right. And you remember these are all equal values of resistance. If not, the motor's not going to work properly. Okay. It's going to change its value. So when we look at basically a 3-phase motor and the voltage, as I said, the voltage drops, but the current stays the same. All right. The current will start off at the same at 400 volts, but stay the same. All right, but it will drop down in value because I've dropped my voltage. But all I'm saying is the current stays the same through the both windings. All right. So when we look at a delta, okay, different again. All right. We have the 6 windings, and we do the windings again, but this time we put 3 bars across. So to look at that again, we've got A, B, C, C, A, B. We put 3 windings from there, and that's our supply coming in. All right, so normally my windings will run across from C to C and that. So if we look at that, that is like 2 windings in parallel, which I'll go back to here. So if we do the triangle, delta means the symbol of a triangle. So normally I'll put a join here and a join here and a join here. So it'll be A, A1, which we go then to C, C1, C, all right. We've gone now from back to C, and C will go to B1, okay, so B1 and A1A, all right, A1 goes to C, right, B goes to B, A1, and C goes to B1. There we go. And we've got our 3 windings. So our power comes out of there, there, and across there. So we end up with 400 volts. So we've got 400 volts across each winding, but the current has to split between the 2 windings. Okay, so P equals V times I. If the voltage goes up, so does the current. All right, but as I said to you, we'll have a look at that. what I'm going to do in the next video, we're going to have a look at how to measure a three-phase motor.